Okay.
Okay.
Yes.
Okay.
So, we're on.
So still alive.
There we go. Stay back. All right. Hi everyone. Thank you. Please.
I'll stand by right here. Uh, Thank you for coming. My name is Ingve, and I work here at the Aurum, and we're happy to host this Angular meetup. It's the second time actually we're hosting an Angular meetup, and we think it's awesome to get this community back and kicking after a couple of years of COVID and whatnot. So, just a couple of practicalities. I've already told you, help yourself to drinks in the fridge over there, and there are toilets on each side at the end of the halls. So I'm not going to take up more of your time. I'll leave it to you.
Thank you so much, Ingve, for having us today. This is just fantastic. They are responsible for the food and the whole thing, what he just said. Um, I want to welcome you all to Angular Oslo, hashtag ngOslo. Please tweet and like and subscribe and all these things. Today we have announced that we would have two speakers, Manfred Steyer and Ryan Hamkamp. Unfortunately, Manfred Steyer got sick, so he will not be joining us today, but Rainer, his colleague, will take over and do his talks. We will have a short break for food and some more snacks. And a quiz at the end. And the quiz is just for people that would be attending. So please come next time. We will be here also. In the end, I'd like to thank the community. Thank you guys for coming, and remind you everyone that tomorrow also we have a full day workshop with Rainer, with all the news that's happening in Angular. Be sure to pick his brain when you're here today or tomorrow, and I can still get you a ticket for tomorrow's workshop if you don't have one. So contact me. Okay, that would be it for me. I'll leave it to Rainer to give talk.
Thank you. Okay, so hello, and also thanks for the introduction. I should so best wishes to Manfred. He's sorry he became suddenly a little bit sick and had to cancel. But I will take over his talk as well. So we are not that many people, so I would say if somebody of you have a question during my talk, then please just interrupt me and ask me. That's perfectly fine. So about myself, so I'm Rainer. I come from Austria. I'm also part of Angular architecture. Oh yes, that's a good idea. Yeah, the problem is we have now two screens. The one that I share will not be the one they are representing. So yeah. Let me quickly check if I can manage that we have just one screen. And that should be easier. Okay. That's a little bit better. Right. Which screen is now shared? Which one do you see on YouTube?
I see your presentation.
And not my notes.
Not your notes.
Great. And if I'm switching over to IntelliJ and you still see my slides, you have to let me know. Okay. Good. So again, my name is Rainer. I come from Austria. I'm part of Angular Architects. There I'm responsible also for some of the workshops that we do, for some of the content, and I'm also active in the Angular community. So for example, I do this NG News, which is a weekly video, which should just get you updated about the latest events in Angular. It just lasts 100. Always some kind of danger if you want to tweak it to your own needs and you really maybe don't have the requirement, because then you are very open for new bugs, and this is something you should definitely have to avoid. But now with the latest developments in Angular, we see that in the foreseeable future, it will be becoming very important to understand what change detection is all about and how it works. And I will explain and I will say why at the very end. So before we go to the slides, I will present the application that I will use to work on, and it will also be the same then in the second talk. So this is an application that I use most of my time, and it's a travel agency, an imaginary one, which does not exist, but you can click here as an end user on holidays, then you're getting some potential holidays, and if you're lucky, then there is also a quiz available. And if you open that one for Norway, then you see here some interesting parts. First of all, there is some kind of the current time which is running there, and then there are 4 different questions about Norway for somebody who doesn't live there but want to come here. So just basic things. I can answer them. So if I click here on something, then you see also here the status changes. It says correct or not correct. So the counter is also there. And by the way, the questions that I'm using here, those have been created by somebody who is from Sweden. So I hope he was honest in providing the solutions. Yeah, if not, you have to tell me. So that's the way how a user interface looks like. And since some time now, we have the Angular developer tools available. That's a plugin for your browser, which you can install. And if you do that, then you get here this kind of button. Let me make it larger a little bit. And the nice thing what it has is that it has a profiler which shows you how often the change detection in Angular runs. So you just need to click here, and you need to scroll to the down, and then you see quite on a regular basis something runs. So we could say things are happening quite often there, which is maybe not good if you don't know where it comes from. Now, if we look at our application, we can say, yeah, probably it has something to do with this timer here, which runs. And if we then go directly into the code, and I'm opening the quiz component TS, that's the component which is responsible for it, then it's not that important to go through all the template there, but you see that maybe if you're working with one of the older versions of Angular, which is something which is very unfamiliar, that I'm accessing the properties by calling them like a function. So we see it here now, which is the current time. We see it also here in questions and somewhere else as well. So there are some function calls, and the good thing about them is, if I scroll down to my class, to my TypeScript code, that most of them are signals. So who of you is already using signals? So just general question. Okay, so for those of you who are not using them, signals are made to be called in the template. It's not a sin, you have to do it like this, because otherwise you don't get the real value out of it. And that's why we can say in this case, as long as they are signals, it's just fine to call them. But if I scroll to the very end, you see there is this now, this is now a function, it's not a signal, and it returns the current date. Good. So I could say, okay, maybe we know that calling functions in the template is not the optimal way how to do it. It might have a bad impact on the change detection, maybe, but maybe this is exactly the problem that we have here. So what if I just go to the template back again, And I say, well, then just don't show the current time, because maybe then this kind of change detection that it runs all the time should go away. So if I now go back and I say here, okay, page has been reloaded, and I click on the profiler again, on recording, we see that nothing has changed. And now it's starting to become a little bit strange, because we don't see here any change in the template. It stays as it is. Still, the change detection is running quite often. So that's a little bit of a problem. So we have to know a little bit about the background of change detection, and especially how it is triggered. That's key here. So if we go back to the slides, so the way how it works is that usually from the perspective of the Angular framework, there are two views. There is one, let's call it the TypeScript class, and then there is the other one, which is the DOM that we see as end users in the browser. Now, usually they should be in sync, so that the data that we have in the TypeScript classes in the form of properties, they should be the same as in the DOM. This is usually the way how it works. And as we know from developing Angular applications, if we change somewhere a property like magic, immediately the DOM gets the update and we see the new value there reflected. Now, let's say we have this kind of a use case that somewhere in this component tree, somewhere a property of a component is changed, it gets a new value, reassignment, whatever. Now, what Angular has to do, first of all, there needs to be somebody who's telling Angular, now it's time to run the change detection. This is something which comes afterwards. But let's not just see the change detection has been initialized, has been triggered by somebody. And the way how it works then is that Angular starts at the root component, which usually is the app component. It checks if the same properties that it has in the TypeScript class are also the same that we find in the DOM. And it has to continue this process for the complete component tree. It has to search, or it has to find out if there was actually a change. Angular doesn't know at the moment. It just doesn't know if there was a change and where the change happened. But once it reaches this kind of component, which is here in yellow color, then it says, yeah, there is a difference. And then Angular is updating the DOM. But the nice thing, or the performant thing about the update mechanism there is that Angular doesn't re-render or kind of redraw the complete component. Angular knows exactly where this kind of text node, or if it's a label, where it is shown, and it only changes that piece of the part. So it could be just one DOM node which is changed. So this is something that is really good for the change detection, because when it comes to manipulating or accessing the DOM, that's always very expensive. But if Angular says, well, I'm only updating only exactly those kind of things that really have to be updated, then we are extremely efficient when it comes to DOM manipulation. The problem is something else. The problem is that Angular doesn't know where the change happened, and it also doesn't know when or if actually a change has happened. But that's the way how it usually is. So it really needs to go through the complete component tree. Now in Angular, there are two ways on how the change detection can be executed, can be triggered. There are just two ways. I mean, of course, there are always some kind of edge cases, but in general, we say it has to be a handled DOM event. So whenever the browser is dispatching a DOM event, and it also has an event listener, that's also important. So it's not just important that I click somewhere, I also have to have an Angular event listener for that. Then the change detection is triggered after the synchronous execution has ended. So the event listener, the function starts to do its stuff. Very likely it's going to change some of the properties in the component, and only after then does Angular trigger the change detection. This is one thing. The other thing, which is a little bit logical if you think about it, if we in our event listener, if we start an HTTP request or something like this, then we don't really know when the response comes back. But when the response comes back, we know that there will be probably a change in the component. So that's why the second trigger is actually the ending of asynchronous tasks. And for both things, Angular is using Zone.js. This is this library which is able to detect when a DOM event happened and also when an asynchronous task has ended as well. And the zone.js is then going to Angular, or it's actually part of Angular, but it's written just triggering the change detection and says, chances are high that somewhere something has changed. Go search for it, and if you find something, update the DOM. That's how it is. Very simple. Now, if we go back to our component, we still don't know why the change detection is running. I think what we know. Oh, go back to the code. What we know by now is that just calling a function in the template will not trigger the change detection. So it was never really this kind of last rendering with the now method that we had there. It was something else. And if you remember, I didn't click on anything, still the change detection was executed. So it could be only the second trigger, which is an asynchronous task. And this is something which I didn't show you because there is one. And it's hidden here in the app quiz status. Where's my mouse? So here we have this component, subcomponent. And if I open it, you see here that there is some kind of a countdown which says, well, you don't have, there is a limit on how you have to finish this quiz. And this countdown is generated here by an interval. So we are using here RxJS to produce an interval, an asynchronous task, which runs every second and which is then always triggering the change detection. So this is where the problem comes from. Which would now also mean on the other side, if I say I'm going to comment the interval, then no asynchronous task runs. And if I go back and then to my browser and go to my profiler, and I'm going to record it, then we see that nothing happens. Except I click somewhere where we have a handled event listener, for example, here on an answer. Then we see that here a change detection was executed. So that's the basics. That's the way how Angular works, if you don't change anything. And there's also another nice slide, hopefully, which shows this again, but now a little bit in terms of animation. So with the default strategy, that's what I meant. If you don't change anything, the default strategy is running. Angular is waiting for an event because that's the usual trigger. We click somewhere, and then there is something which is important for later, but not for now. But when a component has, for example, a DOM event, then this DOM event is also marked internally as dirty. And this kind of dirty marking is then also applied to all its parents. This is also happening, but with the default strategy, it just doesn't matter because Zone.js will say, yeah, there was a DOM event, just check all the components that you have there and find or try to find somewhere a difference. But still, dirty marking is there. Why do we need dirty marking? Well, we can change the strategy of the change detection. We have the option to do that, and that's what I said in the beginning. I'm always very careful, careful if you do this. You can say that change detection in that sense, or the triggering, should still stay the same, but you can now say that the strategy is called onPush, and onPush means that you are defining certain conditions, criteria, when Angular, when the change detection really goes through a component. And the criteria with onPush is the dirty marking. That is important. So a component needs to be marked as dirty, and only then, when the component is, of course, onPush, gets the change detection into the component and does its checks. One important thing about dirty marking is that the asynchronous task is not marking a component as dirty marking. And I think that's one of the main drawbacks when you are applying the onPush, because all of a sudden things that worked before aren't working anymore, especially if they were based on asynchronous tasks. That's really important. So how does it work? We have here again the same drawing from before. This is now again a click event, and you see that now the component tree looks a little bit different. We have now different colors. So on the right side of the component tree, there is a red border or a dark red border, and that means that these components have been marked as onPush. So they are not rendered, not rendered, but they are in a way kind of excluded from the default change detection. Now what happens if I'm clicking here on an event, that it depends on which kind of component this event was triggered. In our case, it was in the default component. So the dirty marking happens only for the left side up to the app component. And then when the change detection starts, the change detection says, okay, default checking will be done for the left side. I will go through all of them. But the right side, I see that already the first one has already the on push. And since it's not marked as dirty, I'm just going to ignore it. And if we have there something where maybe a value has changed and we would expect that the value now is also updated to the DOM, it's not going to work. This is on push together with default when the dirty marking happens only on the default components. And of course, when it happens on an on push component, it's a different story. So when I say here, I'm clicking on a component with on push, then the DOM event is marking this component, and again, all its parents again is dirty. We are going up the complete DOM tree. And what happens then for the change detection, or what the change detection then has to do? Well, it says the default ones are going to be always checked, but now I see that all the on push components are also dirty, so I need to go all of them again. So now everything is in a way kind of checked. Good. So coming back to our application, we could say, and let me quickly go back. So I'm going to reinstantiate the interval as it was. Good. Now I go to my quiz component, and I say there at the very top, I want to set change detection to on push. Something like this. I just give it a try and see what's going to happen. So if I go back, we see that the screen in a way has frozen. So the current time is not updated anymore. The counter doesn't go down anymore, so nothing works anymore. And that's what I said before. There are now some asynchronous tasks running internally, but the change detection just skips the quiz component and also the status component. That does not mean that the change detection doesn't run anymore. We could actually measure this again with our dev tools. So if I click here again on Profiler, then you see that the change detection is running quite regularly again. But the point is, it's not checking the quiz component and also not the quiz status component, because they have kind of opted out from the change detection cycle. And you can also see it. So I mean, this is something I haven't done before. If you click here on one of these bars, then the DevTools also show you what kind of components have been checked. And in our case, the quiz will never show up. Will never show up until I mark it, of course, as dirty. So I said before that maybe a handled DOM event could do the trick. So if I click here, for example, on one of these buttons, then please watch the time and also the seconds there. Now it's updated. Now it says, yeah, I'm now marked as dirty. The DOM event is also triggering the change detection, and that's now why the whole thing happens there. Okay. Good. Let me quickly take a look at the slides. If I missed something to tell you, show that an asynchronous task. Yeah, maybe we can do that one as well. Because I said before, asynchronous tasks don't have any effect. We have already seen this with an interval, but we can also see it directly in the quiz component. It's very obvious. For example, let me say here in the title, I have a message, a property of a message or a field, and I say in the beginning, it has the value hello. And then I have an asynchronous task in the constructor of my component, which just says, I'm going to change this message to hey or whatever, but after 1 second. So an asynchronous task changing the property, which usually works without any problems. So if I say here Windows set timeout, and I say this message equals hey, and I say this should happen after 1 second. And because we also might want to see that this really happens, let's also do a console log. So I say here this message log, but I also see it in the console, obviously. And if I now go back to my application, also open the console, sorry, Let me do this again. So reloading it. It says here, hey, but here it still says hello. What would I have to do if I want to see the hey? Pardon? Click on something. Yes, exactly. So I just need to click here on this, and then we see the text has changed to hey. And now, I mean, we have now seen a little bit about the change detection on push. I think it's clear that it can cause a risk. It is of course a performance improvement, but it also causes this kind of risk. And now we are going a little bit deeper, and we'll discuss all the different criteria when an on push really is marked as dirty, or when Angular marks a component as dirty. In order to do that, I am going to remove all that stuff because there is already too much code there. And I also remove it from there. And what I'm going to do is that I will go into my quiz component and I say, well, I want to mark that one, the status one, which shows the countdown and which also shows the status. Obviously, I also want to mark that one as on push as well. Good. So back to the slides. Yeah. Usually I wanted to show one of the other, but what we see here are the 5 criteria when a component is marked as dirty. An immutable property binding, it's important that it's immutable, so that's why it's bold. The handle DOM event, also important. We could also do it manually, although I would highly discourage you from doing that. The async pipe can also do it, and we have, since Angular 17, we have a new kind of way on how to do it via a signal. And that comes as a bonus because with a signal and an on push together, we can do something which is called the local change detection. This was not something which was possible before 17. Now about immutable property binding. Immutable property binding means that my component, which is on push, updates or is marked as dirty if one of its input values changes. In our case, we have here the time started, and we also have here the status one. So in case of time started, you just need to provide a new date instance. Then you have a new object. With the status, I'd say there is a risk that you could do it wrong. What do I mean by this? It always depends what the parent component is doing. So if I go here to my quiz component, and if I click on a button, then this answer function here is executed. And you see that the answer function update the status, and it's done correctly. So what we're doing here, with every click, we are kind of regenerating a new status object, which is then passed down to the child component, and it's always a new object reference. That's the way how it has to be. If you say, no, why do I want to do this? I just go to reset the values. So I say the status of unanswered is 0. The correct ones is also 0, and incorrect ones is also 0, then you are doing a mutable change, which means that the change detection now for the status will not be called, or the change detection will just skip the status component. So if I go back and my application re-renders, then please note this is here the status component. And if I now click on an answer which is wrong, then we see that something happens in the outer and the parent component. We are getting here the information that's the wrong answer, but when it comes to the status component, nothing happens because it's not an immutable property binding which I've done. That's very important. So it really has to be something like this, so you just clone it. So usually you clone it. That's the way how we usually do it. Good. There is something else. You see here time started. This is a little bit interesting. So there is this function of a reset. So I have the possibility to say in the middle of the quiz, I want to do it anymore. I want to restart in that sense. Then the load quiz is re-executed. It fetches the quiz data, and then it says the time started to a new date, which should actually mean that we are talking here about, in this case, it's a signal. In this case, we are talking about an immutable property binding again, which should mean that, well, the status component is updated. Just need to click on the reset button, this one. So I go back and please again, watch now, especially the time left. I mean, we don't see it here because we have disabled it, but if I click now on reset, the strange thing is, which might come as a surprise in the beginning when you see this for the first time, that it doesn't kind of goes back to 800, 180, but it just goes to different, completely different number. And if I again click on it, it has another number. The faster I click on it, the higher the chances that I reach 180. The question is why? Why is that? If we go into the quiz status component, then we see that first of all, the time started is there. This is not something new. And if we take a look at how this kind of time left or how this countdown works, we have here this interval again, which we have already seen before. Now, does somebody have an idea or does somebody know why the countdown behaves like this? Why does it really not go back to 180 if I click on reset, but just like a randomized number? I mean, I can put here in a console log, you would see that the asynchronous task is running. So it's not a trick or something I didn't tell you, as I did in the beginning. It's really running. So the asynchronous task is running. I can guarantee you that.
You getting the previous value?
No. Yes, in a way, the previous value, and then.
Then the change the text mask.
Yes. And why is it not updated?
It is, but it's updating with the old value.
No, it's updated with the new one. But the problem is it's updated within an asynchronous task, which does not mark it as dirty. So what we have here, I'm going to explain it. We would have two different updates, which should happen within a second. The first update of the time started comes immediately. That's a mutable property binding that works. We have seen that this works. Now we would have thought that, of course, now this is the new date, that when the interval kicks in, that then the interval is, of course, then updating the time, and we see the new value. The problem is the interval is updating it, but it's not marking the component as dirty. And that's why we don't see the real value which we would have expected. Very strange, but that's the way how it is. This is this problem with this asynchronous task that it doesn't kind of mark the component as dirty anymore. Careful about that. So that was immutable property binding. The next one, the other one, is handled DOM events. Again, it is important that it is handled. So if I go back to my status, and if I would add here just one button somewhere, maybe here, and I say click me, and this button it looks a little bit better, then I have there a button, and I would now guess, well, if you click on this button, then of course the change detection will also run for the status because it's marked as dirty. This is a DOM event. It is a DOM event, but it's not a handled DOM event. There is no event listener there. And Angular says if there is no event listener there, then nothing can change to the TypeScript class internally. So why do you expect me to mark this component as dirty? There is no reason for that. But of course, if I say, yeah, there is a click, I mean, I just need to provide some kind of an event handler. I don't need to do anything. It's just important that something is there that says, there is a function available. This is already enough. But Angular says, okay, then I need to mark this component as dirty because I don't know what they are doing inside of this handler function. So if I click here on it, you see the time, then it's also updated. And not just the time left, but you also see here the last rendering as well, which is something I didn't kind of highlight before. The current time is also highlighted or is also updated because mark for check always goes to the top. So it's not just the quiz status which is marked as dirty, also the quiz component and the app component, or if there would be some other parent components in between, they would also be marked as dirty. It always goes up. Good. So that's about the handled DOM events. The other one is manually triggering or manually doing the check, the mark for check function. Depending on which answer you see on Stack Overflow, you might go with an alternative. Stack Overflow answers have this kind of behavior that they're not very explained all the time. So you just copy and paste it, and then you hope that it's working. And if it works, you're happy. But very often I see the following thing. We need to import, we need to inject the change detect reference, change detect ref. And we have here our asynchronous task. And we say, well, whenever the time left is updated, I'm going to mark this component now as dirty. Because although the asynchronous task does not mark it as dirty, but it will still trigger the change detection. So if I am able to mark it as dirty before it triggers the change detection, it will get updated. That's the basic idea behind it. So if I say here, CDR, and this is what I see very often, detect changes. And if I go back to my application, then we see that it works. So the time left is updated, but the last rendering is not. And maybe this is not the best thing that you can do, because you are not marking the component as dirty. You're saying run the change detection. And as you see, the change detection does only run for the component, for the quiz status component itself, but not to the outside. And maybe you don't want to trigger an additional change detection run. You want to wait until the real one comes, which means it would be better in this case if you mark it just for check. And once then the real change detection cycle comes along, it will update it automatically. Because change detection will run always with the asynchronous task. So the better in this case would be here mark for check. If I now go back, we will see that the countdown goes down. The problem still is that the rendering is now also updated. Depending if you want this feature or not, it might be good or bad. Yeah, and then we have the async pipe, and then we'll see what we can do about the signal change, and then we are done. So the async pipe. The async pipe has a trick inside of it. The async pipe internally runs also mark for check. So we don't need to do this on our own. As soon as we use the async pipe, it's done for us. The only thing which I need to change now is that I need to make sure that this time left property here becomes an observable, so that I can apply the async pipe to it. So in my case, I say time left. We know how that notation goes. I'm moving the interval up here. And what do I have to do? Well, I need to say here, this is now a map operator, because I'm not going to subscribe to it. And I say this, what you have done here, please copy it, get away with the subscription. And here return just the number which comes out of it. And again, I have these issues with the brackets there, or don't I have this issue? This one too much. Yep. Now it's better. So I have now an observable of number. It would also be good if this one starts already with an initial value. Don't need to use a behavior subject, but what I can do instead is that I just say start with. Will emit synchronously the 0, or in our case 180. And yeah, then here above, I also need to do some changes. By the way, if you ask yourself what this kind of syntax here is doing in this template, it's something which was introduced in Angular 17. They have replaced the ngIf, the ngFor, and the ngSwitch with so-called template blocks. This is an if, the for, and also the switch. And this means now that you don't need to import the structural directives anymore, but they're directly integrated into the Angular compiler itself. So that it just comes out of the box. And that's also the recommended way on how to do it. So what I say here is that I say, okay, we have our time left, the observable. I'm running the async pipe on it. And then I say, okay, I guess you know this pattern. You create here an alias, you say time left. And then I just move this one down, going to reformat it. And as we will see, the async pipe will now also mark it as dirty. So if I go back, we load the application, we see the current time, the last rendering, and also the countdown works. Good. This was everything that marked the component as dirty until Angular 17. and then the local change detection came out. And for that, we are going back to the slide that we had before. This one here, okay, there's something wrong. When you have a component with on push, and when you use a signal in the template, then you have the local change detection. This means when an event happens in the on push, and in this case, it's not a DOM event, but it's a signal change. It's important that it doesn't have to be a DOM event, because then you have the usual mark for dirty checking strategy. It has to be a signal change. Then only this particular component is marked as dirty and not its parents. There is then also an additional information in the parents components where the change detection knows, yeah, when it, for example, when it hits here, where is my mouse? Yep. When it, for example, hits here this component, then it knows, although this component is not dirty, a child component of it is marked as check. So it skips, in a way, it does not check the particular component, but it still goes through into the children itself, because it needs to find this component at the very bottom, which is doing the local change detection. And then, of course, the default change detection says, yeah, the change detection says, yes, I'm going to check the default components, but also the single one at the very bottom there, and I will also check for that one. And this would now mean, if I'm able to set in the quiz status a signal that changes, that the time left, that the countdown is updated every second, but not the last rendering, because the last rendering it's not the current time, but it should really show us that there is a change detection that happens there, which we don't require. So what do I have to do? Well, I have already my interval. This is already everything set up. So if I want to get here a signal out of it, I just say, okay, I'm going to apply here the toSignal. So there are these interoperability functions, and the toSignal will then, as you see, return me now a signal of type number undefined. And now I have multiple options, or I can improve it a little bit. First of all, I don't need to use take until destroyed. Signal is now taking care for that. Don't need to think about this anymore. And the signal here is undefined, because an observable potentially doesn't emit a value synchronously. So the signal just plays it safe. But we can say, hey, look, I can guarantee you, or regardless what the observable will do, just go on and use as initial value the 180. And then you see then immediately the signal changes from an undefined or number just to a number. And I can also get rid of the start with here. And in my template, I need to say the if with the async pipe is not necessary anymore. I just use the signals as they are. So just normal access, signal access by calling it. And if everything works, if I now go back, then the countdown works, but the time stays the same until, of course, I click on a certain button. Then the last ringer updates itself, but this is actually what we wanted. So we have now a very performant component. We could even continue, which is not what I'm going to do now. You could then also say, yeah, wait, maybe I also want to mark the app component as on push. That is also possible. But as I said, I think that's already enough. So coming now to the one thing that I've promised you at the very beginning, where I said change detection will become important because of current developments. First of all, careful with on push. In normal applications where Zone.js is running, you have seen what could happen. But Angular has the plan to go zoneless, so they want to get rid of Zone.js as soon as possible. And there are currently two approaches, two strategies. In the beginning, they meant that they just bring out the signal components. Signal components will then work without Zone.js, but then of course they understood that maybe it will take a little bit more time until the signal component will be released, and then might come up with a plan 2 or an alternative. And the alternative is a new scheduler, which will replace Zone.js. The new scheduler works like this, that all your components will be on push, but since no one's triggering the change detection anymore, the mark for check functions that we have seen and learned now all the time, they will be the trigger for the change detection. and the scheduler will collect them, these calls, and will then once trigger the change detection asynchronously. That's the current plan, what we have seen. This scheduler is already available as a private method since 17.2, I think. It's private, so you shouldn't really use it. But if you're curious, you can see it already, and there are already some examples on the internet. And the last one is, of course, then with signal components. So if everything that you use in a template is based on a signal, then the signals will take care that you have this kind of local optimized change detection that you have seen. And then zone.js is, of course, also not necessary. But for the signal components, in order to get them, we also need to make sure that all the libraries also work with signals, so third-party dependencies, and that will probably take a little bit longer. Yeah, and that was it from my side for the first part. Are there some questions?
Everything perfectly clear.
Good, wonderful. If not, then you have here a QR code. You have the slides. It goes actually to the GitHub repository, where you also have a solution branch, the slides, and then also some links to other articles where this topic is covered in more detail. Please.
So do you expect with this deprecation of zone.js that we will go away with the change detection strategies also, right? Like, because we don't need default.
Yeah, of course, yeah. So the mark for check will then trigger the change detection. So you have to make sure that mark for check runs, which is a little bit problematic with asynchronous tasks. So we will see what this really means. The best way what you can do is that you put it into a signal, and when the signal changes asynchronously, then you are always on the safe side. But they said already multiple times, this scheduler, this intermediate step towards signal components, is really there if you really require zoneless. The better if you have more time, wait for the signal components, because then it will be way more easier to deal with them, because you just need to update the signal and that's it. You don't need to care about asynchronous or whenever mark for checks run.
There was one more question.
Good, thank you.
Thank you so much. That was your talk.
Yes,
so I'll step into the camera. So you'll be on. Oh, you too. Yeah. So that was the first talk with Rainer, and we'll have a short break with some pizza. It's on its way up. Have some snacks, pick his brain more, and talk. You mingle, get to know other people. And we'll see you guys live in, I don't know, 15 minutes or so, depends on how I feel like.
Yeah.
And it seems like, yeah, we're a bit after the schedule that we set up.
Okay.
So it depends a bit on like how you guys feel about, the break and how long you're available after, but we'll take that off mic. Thank you for now.
Okay, yeah, thanks for now, and see you in 15 minutes. How long did I? Okay. I think I'm not going to full screen because then my Mac always opens a second screen and then I never know which one I'm sharing. So if it's fine, I'll just keep it like this. Good. Then I think we can continue with the second talk. Completely different topic. Signals are also included, but now even more, but nothing in terms of change detection anymore. So this is about the signal store, the ngRx signal store. And before I continue or actually start, just to get an idea, who of you is using a state management library? Okay, just one. Is it come to, okay, from ngRx or something else? ngRx. Okay, good. Now we have a third store from ngRx because from ngRx we had in the past the so-called global store. Then there came out the component store, and now we have a new one. So I think I'm not going to explain the signal store coming from a direction of state management then, but maybe more from the signals perspective. So when Angular first announced that they want to release the signals, many of us ask themselves, what does this mean? Because the way how they kind of described it, that they said there is reactivity in it, there is the possibility of derived state, there is then also this kind of immutability. These are all kind of features we knew already from state management. So in that sense, we thought, okay, is Angular actually developing now a real state management library, which is going to replace the others? And the answer is not really. So the signals as they are very lightweight. They do not replace the state management, and they work for values which I would say are very simple in their structure. But I mean, if you just need to look at the examples that you find with signals, it's just a number or a string, but you never see something, a signal holding an object literal, which has arrays in it or nested properties and that stuff. But we have this in our application. So we want to store complicated objects in a signal. And we also have sometimes the need to add some logic to it, because maybe it's not just storing data, but maybe there is also some logic behind it. And this is where the signal store becomes interesting, because the signal store builds on top of the signal type of Angular itself. So it's fresh, it's really modern, really new. The internal type, as you see here in the slide, is the signal, which means the signal store inherits all the features of the signal itself. Also, the behavior is, of course, very likely as the signals. But on top of it, it adds functions which we really require when we require more. So in a sense, the signal store consists of these functions that we see here, and the art of using the signal store is finding a way how to combine them together. This is here, as it says here in a nutshell, it's a lightweight state management, but fully based on signals. And it gives you one place, a guideline, how you can put a state or a signal and its logic together. Now, before we continue, we have already seen our application. It's again the quiz application. So if I go to holidays, I can click on the quiz, then I'm back where we almost left off. But this time it's a different implementation. It's now just one component, not a quiz status component. I also don't use here on push, and everything is a signal. So there is no normal property there anymore. So if I scroll down, we see here, this looks already a little bit different. We have here a quiz. This is the signal. And from that signal, we say we need to come up with derived values. We need to get the questions. We need to store the title. And we need to also find out the time in seconds. And this all comes from this huge object literal here, which is stored in one single signal. Good. The way how we react to this, or how we get access to this ID, this might also be interesting. We have here the input required. This is something which was released in 17.1. This is the property binding, which
is an alternative or which will replace in the future the input decorator for you. And it has one or two important features. The first one is that the input function gives you back a signal, a read-only signal. And the other one, you see it here, required. So it's a type-safe required function, which means when you say this is a property binding, which is necessary, which is required, then you don't have to deal anymore with the union type of an undefined or the actual property. So this is really cool. And in our constructor, we have here an effect, and the effect says whenever this ID changes, so whenever the property binding changes, I'm going to run the quiz service. There is a function for that, which collects the data from the backend, probably, and then in the end, I'm updating here my other signal again, which will then lead to updates of questions, titles, time in seconds, and so on and so forth. So, and now we are going to introduce that as signal store. So the plan is that, as I said before, we try to put the complete data into a single signal. We add them some logic to it, and we try to have all the logic and the data in one place. That's what the signal store is all about, and that's also more or less what state management is doing. So I've already here created a new file. I call it signal store, quiz store, and I have to call the function signal store. So with the signal store, as you will see now, everything is a function. We don't see any class anymore. It's just purely functional based. There are some reasons for that, which we can talk about afterwards, but for now, let's just say it's a function. We can add now multiple features to this signal store. The first feature we want to add is probably the state itself. So we want to have a container where we can store our state. And we do this by saying with state. So there are with functions which add features to our signal store. With state contains the value, the initial value. And because I have it already here in my component, I just say, okay, I'm going to take this and put it here into the with state. So what the signal store is now doing for me, it is generating me a class. And this is now something, at least for Angular developers, I call it quiz store, which is very unfamiliar. Because the quiz store, as you see here, I have typed it as with a capital initial Q. And there's a reason for it, because the quiz store is not an instance of a class, it is a class. So if I want to get an instance of the quiz store, what I would have to do is that I have to instantiate it. So this const itself is a class. And it's not just a class, it's also an Angular service already, which means it has the injectable decorator already applied. Don't see it here, this is done internally. And we have now the option to choose between so-called local and global state management. I could say that this quiz store is a singleton, so I would have the possibility to say they're provided in root, which I'm not going to do, because I say I want to use the signal store only for the quiz component. Once the quiz component gets destroyed, same should happen to the quiz store as well. And I can then theoretically have multiple quiz components if I want to, and then have an own feature state or an own state management for every component. But in general, it's not a problem. So if you say you want to go with global state because this is what you're used to, then just do it. So because it's a local state, I also need to provide it. So I say here providers, and I say this is the quiz store. And as you see, it can't be found because I didn't export it. Good. Now it's there. And now I can inject it. So now I say, okay, this is the quiz store. Please give it to me. Request now an instance. This is now an instance. And what happens now? If we take here a look at the quiz store, what kind of values it has, then we see that the quiz store exposes the quiz, and that's wrong. Did I make there a problem? Pardon?
You forgot this quiz store.
Ah, thank you. This quiz store, we see here that it contains all the properties already that I have defined in my state. But the interesting thing is, it's not the properties themselves. These are signals of those properties. So I don't need to come up with my own computers anymore. I don't need to provide or come up with a derived state as I've done it here, that I said here computed. I can just say, okay, the quiz which I have here, I don't need it anymore because it was just there to generate questions, title, and time in seconds. And I also don't need to compute it anymore because this quiz store has the questions property already as a signal. Now we see here it says signal of type never. That's something which happens if you forget to add the type. So I say here as question. Could of course also provide here a generic variable, would also be possible. And I have to do now the same for the rest. So I say here quiz store title, and here as well. So quiz store and time in seconds. If you only use the questions, the title or time in seconds in the template, and maybe you don't even have to require these lines anymore because you can just directly access the quiz store from the template itself. That will also be an option. Now with the state coming from the quiz store, from the signal store, there are now some changes. The basic functions of updating the state, they don't work for these signals anymore, so we can't use the update or the set method. We see this immediately if we scroll down here to the first error where it says, the quiz does not exist, but nevertheless we need to update it. And in order to update the quiz store itself, I can't say update, there is no such method. But what I can do instead is that I say patch state. So patch state is a so-called standalone function. You don't need to inject it. You just tell it which kind of state you want to update, which store. In my case, that's the quiz store. And then I just provide the new state like this. So in my case, I say the quiz variable contains all the state already. So I want to override everything already. But because it has the patch name inside of it, it also gives me the option to only selectively update partials of the properties that it has. So I don't have this issue, which I have with the native signals, that in the update method, I always need to return a cloned object which contains all the values. Same is true for set. With patch, I only need to provide those things which I really want to update, and the rest stays as it is. Again, this is a requirement which comes when you are dealing with large objects, and you have this need for a patching function. And also here, so here we are saying quiz update. And again, I say, okay, I don't need to update it anymore. I can't even update it anymore. I just say, okay, patch state, provide my quiz store. And then I can say, well, everything that I'm going to update here are actually the questions. Because you see here, we are returning a clone of the quiz. We need to add the questions, but with patch state, we can only say update the questions and leave the rest as it is. So I can remove this part here. And I say, okay, I have my questions and what I want to do, or I can also come up here with an update method. I'll say that's the quiz, and it should return the questions coming from the quiz itself. So quiz, questions, that will be interesting now with all those parentheses. Does it look all right? No, rebuilding, no. One more, yes, thank you. And the build works again. Yeah, so this was that, and we can also take a look into the quiz component in the template itself, and I think there are no problems. No, so everything should work right now. So if I now go back, and if I reload it, it's working. So that's the state. That's one of the main features that we require. In total, there are 3 of them. The next one is with methods. So what I can do is that I can now add logic to my signal store itself. And we see already that there is some logic included in my component here with the, where do we have it? With the answer method. So if I click on something, the answer method should run through, and I say, well, that's a typical logic thing. I want to move this into my signal state. So I'm going to, again, copy all of it. I go back to my signal state, and there I say with methods, so not with state, but with methods. And what this function expects now from me, that I provide a function where I have full access to the existing state, but I have to return now an object literal which contains methods as its properties. And those methods are then integrated into the signal store itself. And since I said before, I want to provide the answer, I just say here answer. This is what I want to have. And again, I need to do here some kind of changes. So we have a const question. These questions, this is of course wrong, because I just say store questions find. So I'm going to access them like this. The same is true here for the patch state. Quiz store does not exist. Instead, we have the store coming directly from the function. And we're already done. So the quiz store contains now the answer function. And if I go back to my component, there is obviously a problem now in the template because it doesn't find the answer anymore. But here I can say, okay, you have already access to the quiz store. Just call the answer directly. If you want to see what the quiz store is now looks like, you can go here to the constructor, quiz store, and again this is missing. And you see here still the slices, questions, time in seconds, title, but also the answer method. Good. And since this worked already very fine, we say, okay, we have time for another method, which is this one here, where we want to store or we want to load the quiz itself. So I say, okay, I want to have a function which is called load quiz. And I add it here on the very top. So I say load, please give me a number. This is what I would require. And well, now I would have, or I will require now access to another service. Now we have a problem because we don't have here a class, which means we don't have a constructor, which also means we can't use constructor-based dependency injection. We only can use the inject function. It's the only way how we can get access here to the dependency injection. The dependency injection is there. We just have to know where it's available, and it's available right here where I am here with my cursor before I'm returning those methods. Here, the injection context is ready, which means if I call here the inject function, I'm safe. So I say here, I want to get access to this quiz service, which is capable to return me all the quiz data. And then in my load method, I say, okay, I have the ID. The quiz service has a find by ID, and you see here, it's returning, don't see it here anymore. Now you see it returns a promise. If it's an observable, then you would have to subscribe to it. But in this case, it is a promise. And the nice thing about those functions is that I can also make them asynchronous. I just say here async. I take the quiz as it is out from this quiz service. I say await. I have my quiz available. And now we know already what's going to happen. I just say patch state, store, and provide the quiz as it is. And now I have a load function in my signal state, which means, again, my component can now be reduced in terms of TypeScript code. So I can say here, all the stuff that we have here, we just call, the ID is what we require. Oops, no, this is wrong. Here we are, const this ID. So, and I just say this quiz store, load me the quiz with this ID. And in case you haven't used the effect before, the effect is a little bit dangerous because when you run a function inside of an effect which updates another signal, then there is this risk of a cyclic dependency, and therefore you have to opt out manually. So what I would have to say here, when the quiz is loaded, when this function is executed, there is a signal update. So I need to run this in an untracked function, which means the effect doesn't react to any of the signals which the load here is calling internally. Let's see if it's still working. Yep. Sorry. And so on and so forth. Good. So we can add multiple methods to it. The next thing is derived values. So we might not require always the exact type or the exact structure of the value that the signal holds, but maybe something else, a mapped type or something like this. For that, we can use the computed. And we have here one computed, which again is a perfect candidate and that's the status. That's a computed. You know already how this works. We have dealt with it in the last talk. And I say, okay, because I have now the signal store, I don't want to have it here. That's again part which should belong to the signal store. And the signal store says, yeah, you can have a state, you can have logic in terms of methods, but you can also have derived values, and I have there a special function for that as well, and that one's called with computed. The with computed gives me the state, and it works in the same way as with methods. It expects from me to return an object literal containing computed properties, and that's what will then be integrated. So I say, okay, same story again, return. We are returning the status, and since the complete state is based on signals, I don't need to use a special computed function anymore. I can use the native computed function, and in this case, Angular takes full control over all the computation. So from a framework's perspective or from a library's perspective, that's nice because they don't need to come up with something special. In my case, I say, okay, we have our state where the questions are included, and this is what I'm then also going to return. Good. There is, of course, then also somewhere an error. It is here. So again, I say quiz store status and also quiz store status a second time. Anything else? No. We see already we can already now start to remove some services. We don't need the quiz service anymore, and I'm quite sure those can then follow as well. The next one is a little bit tricky because the next one is about integrating RxJS back. So you see here that signals are everywhere, but there are still some use cases where we say we need to require RxJS because an event or a certain method could be called multiple times, and we want to use the power of RxJS to control those multiple events in a way. Now the signal store helps us with this. It says you can use RxJS, but I give you the option to only use it in those places where you really need it and not in general everywhere. So in our case, what could this be? We have here this input of the ID. It could now happen that the parent component, for some reason, is updating it multiple times. So this would be a change where we need to react to it because we would have to start with quiz store load, which would run an HTTP request. And then we are already there where we require RxJS because I say if the ID is updated now for some reason in a second 5 times, then maybe I want to use a switch map or something like this in order to control this a little bit better. What can we do? There is our load method. And this is now, again, a little bit weird, at least it was to me when I first saw this. I'm just calling it load underscore because I'm now creating a new load. And for that, there exists now a special method which is called Rx method. Now what this one's doing, it generates me a function. I also need to define the parameter type of that function. It's a generic function as you see here, so it's number. And then the Rx method says, you say you want the generated function accepts a number as a parameter, but I will now map the function calls to you as if they are observables. So you have now, or I have now the possibility to work against an observable of number, and that observable will always emit when somebody is calling this load function. Which means I don't see here the observable like this, but I have here the pipe method. In the pipe method, I can now apply all my pipe operators, for example, the switch method. So I can now say, okay, when this function, the load is called, I'm going to run now a switch map. I get the ID. We see that's already type safe. It says, yeah, the ID is number because you said you want to have a number from that function. And I say, okay, the quiz service should then call find by ID. Switch map works with promises as well as observables. And then I have my tab function because now I want to patch my state. So the switch map returns me now the quiz, and there I say patch state store and the quiz which I've received. And I can remove it, this part here, the old one, the old load function. So from an observable perspective, I hope that's clearly understood. We get an observable with a number. Every time somebody calls the load, the observable emits a value. And if I call the load 5 times within a second, we know that 4 times the HTTP request will be cancelled. I can also come up with merge map, concat map, exhaust map, whatever I want. All the power which we have from RxJS can now be used here. To the outside, though, the RxJS is hidden away, because to the outside, my quiz store has now just a load function where I can say I give you a number 1, for example. But it's not just about the type of number. The load function also expects or accepts a signal of a number or an observable of a number. So we can also load an observable representing events into it as well, like kind of connecting observables together. In our case, it's not an observable we are going to use, but we are going to use the signal. We are using the signal of the ID, of the input property. Because here I say, okay, I don't want to run, or I don't want to write an effect where I'm going to react whenever the ID changes. I say, you, my dear load function, you are already reactive. You know what a signal is all about. So I'm just giving you the signal of type number, and now you know what to do. And I can remove the effect. I don't need this one anymore, because now the load function takes care of it. And if I go back to my holidays, we see that they are still shown. Of course, I have now not really an option to kind of trigger the ID or the load here multiple times. But I mean, I have done it here with this ID. But be assured, the nice thing is you have your full control over the different calls. The last thing, yes, please.
So this, is there an automatic subscription? And
Yes.
Can you subscribe also?
You don't need. It's an unsubscribable, the type which you get back there, but the signal store will subscribe to you, and once the signal store gets destroyed, it will also unsubscribe from all its subscriptions. So it has this built-in. In our case, it's a local state management. It's provided per component, which means once the component gets destroyed, also the subscriptions are unsubscribed. The last thing that I'm going to do now is that I'm going to use this Rx method together with the so-called with hooks, because I want to fix, or I want to kind of come up with this interval function which we have here, this kind of timing where we are counting down in a better way. Again, we have here, in a way, we have here the same situation again. We have a reactive type. In this case, it's not a signal of type number, but it's an interval. It's an observable. And what I want to achieve is that I have a method which updates the time left in this case. And it does this by exacting, it executes whenever somebody calls it. And my idea now is that I'm just providing here an interval which emits every second, which means that this time left calculation also happens every second. That's my plan. In order to do this, I need to change here a few things. I need to extend my state. So I need to say here we have a time left, and let's say that's 0 because it will be calculated. And the time in seconds is also there, and we also need to have a time started, which let's just say it's a new date. The rest is then straightforward, at least for the generation of the calculation. So I say here calc time left or set time left. It's a simple method. And we say, okay, what we have done before in the component, namely executing here this one, is something we have to do again. But this time, of course, in the signal store. So the time left set will not work anymore. I have to use my patch state again, where I say, okay, this is now the store. I want to update the time left signal already. Now the patch state really makes sense. And I'm providing here the this time seconds minus time started and whatever. So this one here becomes the store, and here again. So we have now a function which is calculating the time left, and now we just require a trigger, and the trigger will now be an observable of type number. But because again I want to provide an observable, I need to map, or I need to transform now this function into an Rx method. So I say here, look, you need to expect also, I mean, I don't care what actually what value comes out. It could also be void. For me, it's just important that I'm able to be able to expect now an observable. And what I'm going to do is that whenever I'm being called, I'm going to update the state with the new calculated number. And now the parenthesis game starts again. Closing here, closing here, closing here, comma, remove it. Yep. That's a nice thing about automatic code formatting. If the syntax is correct, you see it's formatted nicely. So now we have the Rx method, and now, as I said before, we need the trigger. The trigger is going to be the interval, and there is now a very comfortable or utility function, let's call it like this, with the signal store, which is called with hooks, and that's the perfect place for it. Because with hooks, I have the possibility to define code which runs in the beginning, but also at the end. And in the beginning, I will start the interval and will pass the interval to my calc function. So what do? I would get here my store again. I say we have here the onInit hook, onInit, and I say, okay, store. We have here the calc time left function, and what you will get from me is now an observable this time, not a signal, and it will emit every second. So the connection now happens internally, and to me, to the outside, for the component, it only needs to know how to get access to the time left, and we know already how this works. So I can say here, I'm going to remove this part. Also with this is server. Oh, this is important. Let me quickly add this one. This is server is necessary because we are running here also server-side rendering, and I don't want to start an interval on the server because it will then never end. So I have to be a little bit careful here. So the platform ID, if this platform is server, then I'm going to return it, and otherwise it should start the calculation. So I can remove the constructor. The time left is something I also don't require anymore. Time started, time in seconds is also now part of the signal store. The is server, of course, as well. It's also in the hook. And I just need to find now the place in my component where the time left was used. And this is here. And here I just say, okay, we have it here one time, we have it here a second time. Quiz store. I just add it here. And if the compilation works, then we need to check if now also the timer works. The timer works, but for some reason the questions aren't shown.
You remove the modes from the constructor.
Oh, yes. Thank you. Thank you, thank you. This would have costed me another half an hour searching it. Thanks. So quiz store, we say load, and I see here quiz ID. Battery is also already low. Time to wrap up. This input required, but no value is available yet. Yes, because I called the signal. Don't do this with an input required. You need to really provide the signal as it is. And then everything is as it should. Wonderful. Here we have our quiz. Right answer, right, and we also see here the time left, the countdown is also working. And if I would now remove the questions, the title, and would direct these properties directly from the quiz store in my template, the only thing which is left is the constructor and the ID. You can always go back to your quiz, quiz store in this case. You have here a very structured way how the things or where the things are located, a very clear structure. There is a with state, there is a with methods, with computed with hooks. Everything has its place and everything is together. Good. And by saying that, whenever, where are my slides? Sorry, I can use PowerPoint, forgot about it. We are now already through. So quick summary. Just open all of them. We have seen that the signal store is one of those modern state management libraries which are really embracing the signals. They are not kind of integrating it or are using internally something else and then just exporting a signal. It is really based on signals. We can also use the patch state and slices for a signal state, which is something I have not shown you. But if you want to have a lightweight start into the signal store, there is also a lightweighter alternative. But I can guarantee you that it will not take long until you go to the real signal store. We have also seen that it is very easy to combine asynchronity together with signals, which is always a challenge because signals tend to be very synchronous in their nature. If we require, then we can, of course, also use RxJS. This is not forbidden. We have a structure, some guidelines where the code is located. It's also highly extensible. This is something which I have not shown you. This would be way beyond the time that we have. But there are things where you can very easily come up with template functions, which we can then just plug into different feature states or into different signal stores, and then you can inherit certain functionality. And at the end, we have also seen we can do both. We can use the signal store for global state management, which would require a provided in root, kind of instantiating the signal store as a singleton. But we can also do local state management as I have done it now, where we're providing it in the component itself. And that was it again from my side. If you have any questions, now it's the time. Thanks. Yes.
Yeah, so we have used NGRX for
Yes.
a while, and obviously we have probably a way too large global store.
Yes.
And we've also started introducing component stores around.
Yes.
And now we've started using select signal in
Yes.
the component store and combining with the global state selecting. Do you think this kind of replaces the component store? Or?
Yes. So for the component store, it is obvious. I think I don't know if we have it in a written form in the official documentation, but I have it on record that members of the NGRX team said, yeah, it's going to be the successor of the.
How would you if you need stuff from the global store?
Mm-hmm.
Is that as simple as just doing a select?
Yes,
I mean,
exactly.
Injecting the store. And
Yes.
do a select.
Yes, exactly. You inject just the store in the with methods. You are selecting a signal because probably in the signal store, that's the type that you want to use. And then you can have a communication with them. You can combine both of them. What I just want to say is that I think, although the signal store is of course more towards the component store from its design, it will also in the future and long run also return the global store because it can also be used as a global store. The problem with the global store though is it's not that extensible as the signal store. So unfortunately, this is a feature I haven't shown you. But I always say these are the crown jewels that you can very easily come up with templates where you can have them multiple signal stores very easily getting some kind of functionality.
And I saw there was some on one of the slides with like deep, what you call slices or deep.
Yes.
Deep signals. Is that just a with something in the signal store, or?
It's with state, which returns you a deep signal. And the deep signal has exactly this structure. You don't need to do anything. It's just out of the box. Yes?
You may need to repeat the question for
sorry.
viewers.
Yeah, there are many
I'm not
questions.
Sure if I hear you.
So the first thing, I think the first question was clear from the context from my answer. It was about the relationship of the signal store with the component and the global store, where I said it's clearly from the design that the signal store is going there to replace the component store. And I also think in the long run, it's going to replace the global store because of its extensibility, which we are missing in the global store. We had, for example, those of you who know it, there is this NGRX data project, which was meant to be this kind of a template. We see it failing. With the signal store, there is an extension which is called with entities. And if you look at it, you see how easy it is to do something like this. And it's also very easy to do this on your own. So it's very easy to come up with only extensions. And that's why I think that it's going to replace it.
So I also have a question from online.
Yes.
So a person, I can't really tell, it looks like a cat or a tiger.
Does it have this AA?
ARAM?
Yeah, I know him. Yeah.
Okay. He's asking, is it safe to use date class with state if we care about server-side rendering?
The date class? Yes, why not? Because he's afraid of JSON, but you can use dates. So you'd be surprised if that doesn't work. You can try it out. I mean, you have your server side running, but as far as I know, it just works. So if I say here, we can do a very simple experiment because everything is your server side rendered. I can say new date, just now. The date pipe in that, just say, okay, we have here the formatting, yeah, and please create the field now. This is a new date, and import the date. So it would flip my world upside down if this would not work. It's server-side rendered. So there we are in the preview. Yeah, we don't see it here. Yeah, it's not showing. It's hidden.
With state, are you using with state?
Yeah, if it works like this, it will also work with state. It's just about the serialization is his question. If how they manage to do the serialization from the server to the client, if the date structure stays as it is, which I would say. Yeah, as I said, I would be surprised because I'm using server-side rendering quite often now, and I think I would have seen if there is a problem, but maybe somebody else knows. Yes.
I have actually a couple of questions.
Oh, okay, good.
Some of them a bit older one, but
yes.
So first of all, for a global state,
yes,
when we are using ngRx, we have these 4 feature stores.
Yes.
And modules that
yes.
they encapsulated, and sometimes it's very useful to have possibility in effects to react on some events or actions coming from other feature stores. Is there any way to in the same way react on in this signal store?
Yeah. So the question is about the nice way how we can work in ngRx Global Store, where we have the Redux pattern with the effect, with the reducer, with the actions. Can we do this also in the signal store? No, we can't. There was in the very beginning a question about this, to provide the Redux pattern also for the signal store, because then it would be clear that the signal store is also a replacement for the global store, and there would be no doubt about it. The answer was no at the very beginning. They are open to it. They would see it as a community project, and we are currently working on it. So this Angular architecture where I'm coming from, we are trying to integrate the Redux pattern into the signal store as well. But it would be a third-party library which you would have to install.
Yeah, then thank you. Then the second question, they have this package in ngRx data, I think.
Yes.
With this entity methods like add one, add many, and also for selectors. How this works with, is it works in general?
Yeah. Yes. So the question is, we have the ngRx entity, based on it is the ngRx data, and for the global store, of course. And the question is if there is an alternative for the signal store, and the question is yes. It's called with entities extension. So if you go to the ngRx documentation, you will see just right there where it says with entities, and this is exactly what the entity state is currently doing.
Okay, thank you. And the last one, probably more also Usually there are part of the community that likes facades.
Yes.
If you speak about global store, and part of the community that hates. What do you think as a member of Angular architects in the case of NGRX in general and with global signal store? Do you like facades?
I like facades in general very, yes, especially when we're talking here about modules. So every module should have some kind of an API. And if this is a certain service which kind of presents itself as the single entry point, then you can model this as a facade. And I used to use it for every time when I use the NGRX Global Store. Facade is not just there to, so the question is about the facades. The question is not just there to remove or to decouple the NGRX elements of the store and of the selector of the actions from the rest of the components. It's also there to kind of integrate some logic to come up with encapsulation, where I say not all the actions should be available to the outside. So there are many tasks that a facade can fulfill. And for the signal store, I would not use it, or at least at the moment, I wouldn't use it, because first of all, this decoupling effect is something we don't have. Whereas with the global store, we don't want that our components are working directly with the store service from NGRX. We don't want to have it coupled. That's why we provide methods and properties. The signal store, it's already methods and signals. So this is already in a way a built-in facade. The question is then more about encapsulation. Because maybe I say there are some functions, there are some methods which I don't want to expose to the outside. There are some tricks. We can put the function into a scope and then it will never be accessible from the outside, but it will be there internally. But in general, I also maybe want to say the patch state shouldn't be able to be applied from the outside to an existing signal store. Patch state should only work inside of a signal store. And here again, the NGRX team is thinking about it. This is an answer we got 3 days ago. They say they see the need for it. They still don't know yet how or which version it will be. There are different ways how you can do it. You can do it via the configuration. You can do it via convention, or maybe some other things. And one of them will come out in the future. Yeah. Welcome. But it's an important thing, encapsulation. So we really need this, because for larger applications, you can't just expose everything. It's just chaos.
Yes. Happy guys and girls? So thank you again for a brilliant talk.
Yes, thank you. Thank you.
So I'm not sure, like we dragged the program a little bit. Are you still up for a quiz?
Yes.
Yeah? Yeah? So now I feel terrible because I'm not using your fantastic quiz application.
No problem.
So next time, maybe. So I'll just borrow your stand here.
You wanna connect to the screen?
Yes, please. That'd be nice.
Do Windows. Windows key.
In a few seconds, I'm going to disconnect.
Right.
This works. It's always interesting. Do Windows Core. Big screen.
Too easy. Too easy.
I know. Yes.
Right. Oh no.
We have Windows
Yeah, just realized. How am I supposed to start the quiz without showing you the answers?
Close your eyes, everyone. Oh, by the way, this quiz is just for people that are present, so so I can handle that. We will conclude the online streaming now, and we welcome you all next time.
You can do duplicate the screen or extend the screen just as regular.